Hi, I'm Pablo Pintabona. Just so you know, I'm not a mathematician, just a math enthusiast with an undergraduate degree in economics. Everything you'll see here, work, tools, statement, conclusions, is mine unless I say otherwise. Even though Spanish is my first language, I'm sharing this in English to reach more folks. If you're a Spanish-speaking person, you can make use of YouTube's closed caption tool to follow along. Here's the plan for this presentation. First, to dive into Fermat's methods and apply them to his problems. Second, use this topic as a first approach to some basic number theory in a beginner-friendly way. Third, spark curiosity in math, get people interested, from high schoolers to anyone curious about numbers. Fourth, show that it is possible to reach solutions without resorting to more sophisticated mathematical tools. I do know that subtle tools are crucial for accessing deep insights about numbers, but sometimes the standard learning pace zooms past the joy of using simpler tools. Let's slow down, appreciate the basics, and show how they can solve problems too. Okay, so this presentation has 9 sections. First off, we dive into the Fermat proposed a problem section. We kick things off with an intro about numbers that are sum of 2 squares and why they are so fascinating historically and even today. Then, in the Edwards short descent method, we'll tweak things to make the solution even better. After that, a first Fermatian-like descent gives us an easy example of how an infinite descent works, just as a warm-up. Next section is squaring through Pythagorean triples. It's a quicker way to solve the problem and introduces the Pythagorean theorem, which you probably already know. Then, there's a second Fermatian-like descent and a beautiful formula that gives a short list of possible solutions using the tools from previous sections. Finally, in Is this Fermat's Unpublished Infinite Descent? We'll reshape the beautiful formula to establish a more rigorous infinite descent, which is probably what Fermat discovered but never wrote down for whatever reason. The next section is a streamlined infinite descent, where we improve the method using some calculations from the previous section. Then we've got a simple descent and a formulaic solution. It's a faster descent-only method based on Edwards' descent that eliminates the manipulation of plus-minus signs and only needs one step using Fermat's Little theorem. Additionally, we'll present a formulaic solution using elementary symmetric polynomials to illustrate why this method is so effective. The last section delves into the interconnections among the infinite descent methods presented here, which may potentially be attributed to Fermat, and their correlations with Hermite's simple continued fraction method, along with Brilhart's enhancements.